Okay, so a lot of you have been sick over the last couple of days and have missed out on some really important stuff. So I wanted to make sure that I made a video that explained these things the same way that I've been talking about them in class, and I couldn't quite find one online that did it quite the way I wanted to. So we're going to go ahead and talk about what we missed on Monday and Tuesday, the 5th and 6th of December, when we're starting to talk about triangle congruence. And our big questions are, well, what does it mean for triangles to be congruent? And what is the minimum information to know that two triangles are in fact congruent? So our first step here is just what does it mean when we say two triangles are congruent? So if I start out with a triangle like this, and I have another triangle over here that looks the same, what does it mean when I say those two triangles are congruent, besides the fact that they look the same? So our definition here for congruent triangles is that all of the corresponding angles and sides are the same. And so what that means is, like, if these two triangles are congruent, that side is congruent to that side, and this side is congruent to this side, and the last side is congruent to the last side. And in addition to that, all of the angles are going to be congruent as well. So this angle is congruent to this angle, and this angle is congruent to this angle, and then our last angle is congruent to our last angle. Three of those. And so all three angles pair up with a congruent angle in the other triangle, and all three sides also have a corresponding or matching congruent side in the other triangle. That's what we mean when we say that these two triangles are congruent to each other. Now, if we want to be even more specific here, if I go in and I say, like, this triangle I'm going to call ABC, and this triangle we'll call XYZ. When we say, and by the way, the notation we use here, this symbol means triangle ABC is congruent to triangle XYZ, that statement, which we call the congruence statement, we will use that later. That statement has a lot of information in it. And the order that we write these letters in is actually really, really important to understanding what's happening here. So when we say that the A and the X, we write those both first, that is because A and X are corresponding vertices. The angle A is congruent to the angle X. I'm going to write all these down here. So if I write them first, angle A is congruent to angle X. That's why I wrote both of those first. Then if I pick a different color here, I'm actually going to make my line just a little bit thinner. So the next one in line here is that B and Y are both second. So that would tell us that angle B is congruent to angle Y, angle B is congruent to angle Y. And then the last pair here, we'll do that. C and Z are written together because angle C and angle Z are congruent. And in addition to all of the angles, even the different side lengths are congruent based on the order the letters are written in. So when I look at these and I say, like, you see how AB comes first and XY comes first, that's because side AB is congruent to side XY. So we know that side AB is congruent to XY. If I look at, like, these two, BC and YZ are congruent. And then even the last pair, which is kind of the hardest one to see, but AC and ZX are congruent as well. So in that one congruent statement, we are showing, let's just look at AC and ZX. In that one congruent statement, we are showing the three congruent angles along with the three congruent sides. Once we know the two triangles are congruent, we know all of those angles and all of those sides are congruent. We will come back to that later on. But for right now, the big thing to know is that when we say that two triangles are congruent with our congruent statement, we need to be matching up the corresponding vertices. Now, sorry, that's what it means for two triangles to be congruent. The next question is, well, what is enough information to know that two triangles are congruent? Do we actually need to know that all six of those things are matched up? Or is there less information that we can get away with? And so that's where these congruence shortcuts or congruence criterion, you'll hear them called, come in. And there are 5 of them that do in fact work. And there's another couple that you'll see that look like they should work, but actually don't. And so I'm going to go ahead and just write down real quick here the ones that work on this side and the ones that don't work on this side. And to keep this in mind, we'll talk about these more in a minute. So hold on if you're having some questions here. These are the amount of information that we need in order to know that 2 triangles are congruent. And so the ones that work, we call these the SSS congruence shortcut or congruence criterion, the SAS shortcut, the ASA, the AAS, and the hypotenuse-leg. So S's stand for sides, A's stand for angles, H is hypotenuse, L is leg. Then the ones that don't work are the SSA and the AAA. And so we'll take a look at kind of what each one of these actually looks like in just a second here. And then we'll do some examples of like, are these triangles congruent? Are they not necessarily congruent? That kind of stuff. But all the S's stand for sides, all the A's stand for angles. So let's take a look at SSS first. When we talk about SSS congruence, what we're really saying is that if I have 2 triangles, so there's my 2 triangles. If I have 2 triangles where I know all 3 pairs of sides are congruent to each other. So I know that this side is congruent to this side is congruent to this side, and this side is congruent to this side. That's enough information to know that these 2 triangles as a whole are congruent to each other. 3 sides is enough information. So if I were to call this one A, B, C, and D, E, F, because those 3 sides or 3 pairs of sides are congruent, I know that triangle ABC is congruent to triangle DEF. That's what the SAS conjecture is saying, or SSS conjecture is saying. That 3 pairs of sides is enough information. The next one we had was SAS. And so the order that these are in is what's really, really important. You've got 2 sides and an angle, but the reason the A is written between the 2 S's, so A is between the 2 S's, is because the angle has to be between the 2 sides. So when we draw that picture, and draw my 2 triangles here, I've got a pair of sides that are congruent. I've got another pair of sides that are congruent. Now when I look at where that angle has to be, the angle has to be between the 2 sides. So I got one side here, angle pinched in between them. And then the same on the other triangle, one side here, angle pinched in between them. So in the SAS, you see the A between the 2 S's. That is because the angle has to be between the 2 sides. And then I would know, if I just go ahead and label these, I'm going to do this every time, I think. I know that triangle ABC is congruent to triangle DEF by SAS. And that's the kind of language we're going to use a lot. Now, this would be a good time to kind of contrast that to the SSA that does not work. And so I'm going to go ahead and put SSA, and I'm going to make sure I say does not work. In class, we talked about specifically why this is the case. You would really just need to know that it doesn't work and what it looks like. So what this is going to look like, different from the last one, I still have 2 sides and an angle, but now my angle is not between the 2 S's. Which means when I go to do this on the triangles themselves, the angle is not between the 2 sides. So I still have 2 sides, but now, as just an example, it might be that angle. So the angle not between sides. And when you see this, this is where you got to stop and say, okay, that is SSA. That one does not work. These are not I don't want to say not congruent because they might be congruent, but there's not enough information to prove they're congruent. So you'll see a lot of times necessarily congruent. They are not necessarily congruent. They could be, but we don't know for sure because SSA is not enough to prove it. Okay, let's go ahead and talk about ASA and AAS next. These two both do work. So if I do ASA, this is a good one to do next. This time you'll notice that the S is between the A's. So when we draw our triangles, what we're looking for here is two angles that we know. So there's one pair of angles, there's another pair of angles, and the side has to be between the two angles. So it's that one and that one. Side between angles. That's ASA. And so again, I'm going to go ahead and put down that this is A, B, C, and D, E, F. And so because of ASA, the side between the two angles, I know that triangle ABC is congruent to triangle DEF by ASA. Now, contrast that to the next one. And I am going pretty fast here. Just remember, this is a video. You can rewind. Contrast that to AAS, or you might see it SAA. There's no difference between those two. This time, the big deal is that the S is not between the A's. And so when I draw my triangles, you're going to see that same thing. I'm going to have my two angles still, because there's two A's in this one. But the side I'm talking about is not this one. I'm going to actually go ahead and put an X there. Not this side. It's not that one. If it's that one, they're still congruent, but that's ASA, not AAS. So we're looking at, like, for example, this side. A side that is not between the two angles. That's the key. We write the S between the two angles. If the side has to be between the two angles, we write the S not between the two angles if the side is not between the two angles. Now, it has to be on the same place. You know, if the side is the one attached to the one with 2 marks, it's got to be attached to the one with 2 marks, the angle with 2 marks. If it's different, you know, one was here and one was here, that's not going to work. And so same deal. You know, if I go ahead and label these triangles, doesn't want to stay connected on me. So I know that triangle ABC is congruent to triangle DEF by AAS. Okay, then our last one, you probably wouldn't guess this by just the name, is a little bit different. This one only has 2 letters, but that really doesn't mean that there's only 2 things. There's still 3 things here, because when we say HL, we mean hypotenuse, leg. And we only use the words hypotenuse and leg for right triangles. So this is right triangles only. And because it's only right triangles, it's hypotenuse, leg, and a right angle. Right, so we actually do have 3 things here. So the key to this one is we have to be using right triangles. So we'll know that there's a right angle. You have to have that right angle. You have to know that the hypotenuse are congruent. Hypotenuses, maybe. And you have to know that the legs are congruent. One of the legs is congruent to the corresponding leg in the other one. Right? So we've got a right triangle with a leg and a hypotenuse, a right triangle with a leg and a hypotenuse. So that's enough to know that these 2 triangles are congruent. Now, the last thing I really want to point out with this kind of a question is this really is SSA. It's 2 sides and an angle that's not between them. But because this is a right triangle, it turns out that that eliminates enough of the possibility of different triangles that we can guarantee these two triangles are actually congruent. We did this exploration in class. If you really want to know more, go ahead and go on YouTube and just Google, like, why does HL work? And you will absolutely find some very good examples of, or some very good explanations of why that's true. So the last thing I want to do is just a quick example of what I would expect here. And so what I'm always going to ask for is basically, can two triangles be proven congruent? Which conjecture or shortcut or criterion or whatever you want to call it, and then write the congruence statement. And so I'm just going to go ahead and give one example. This is the example that is in the, if you look at the in-class practice that's linked below this video, it's the example that's in there. So it's drawn out like that. And I think the other one just kind of rotates around like that. And so we see these two triangles, and I believe, I'm just going to hope I'm getting these letters in the right order. Actually, no. A, B, C, and then I think it went D, F, E, like that. So first question is, are these triangles able to be proven congruent, and which conjecture is it? So what I would just start off with is I'd look at these two triangles and say, okay, I have one pair of congruent sides, I have another pair of congruent sides, and I have a pair of congruent angles that happen to be right angles. We'll see if that's important in a second. So I didn't worry about what order I wrote those in. I just wrote down that there's two S's and an A. We can rearrange these if we need to, and we do need to. So what I'm going to look at here with my two S's and an A is, where is the angle? Is it SAS, where the angle is between the two sides, or is it SSA, where the angle is not between the two sides? So I find my two sides, I look where they meet, and yes, that is the angle. That tells me this is SAS. Since SAS was one of the ones that did work, we can say yes, by SAS, triangle ABC, and now we're writing the congruence statement. We got triangle ABC. I'm going to look for where these match up. Angle A, where does it match up to? Use your context clues. Angle A is attached to the side of the triangle that has one congruent mark. Which letter in the other triangle is attached to that same side? Well, here's the one with one congruent mark, and it's attached to D. So D has to go with A. I look at B. B is attached to the side with two congruence marks. Well, so is F. So D, F, and then C is the right angle, so E is the right angle. So C and E go together. So in this case, triangle ABC would be congruent to triangle DFE. And so on the worksheet, it just asks you to circle yes or no. Then you write the congruent state conjecture, and then you write the congruent statement. So you're writing yes, SAS, congruent. So the homework for this, you've got a worksheet that says, like, in class practice. That is linked on the Canvas page. It should be right below this video. In class, we obviously did that together in class. I'll put the answer key right below it. And then you've got Delta Math. I believe this one is 10 questions, but they do go quickly. If you're understanding this as well as you need to understand this, it should take you about 5 minutes to do those 10 questions. If it's taking you 15 minutes, that tells me you don't understand this and you need to be asking more questions. If you're not getting them right, you need to be asking questions, looking at the examples, asking me, something like that. I believe the Delta Math assignment is called like 4.4 or 4.5 practice, because those are the sections in the book that match up with this if you really want to look at the book. So I know that was a pretty long video, but this was a 2-day topic, so covering 2 days what we did in class. That's going to take a while. Get that delta math done. Make sure you're understanding this. Ask questions if you don't, and I will see you later.